All right, we had a lesson not too long ago. Maybe the lesson before last, or maybe, I don't know what it was. You actually had a quiz on it. You actually had a quiz on it. When you had two lines, right? Cut by what? What do we call it? Transversal, right? So we'll make our transversal right here. Is everybody listening? Not everybody's listening. Just listen. Just listen. Just it doesn't matter what it's called. You got your book right there. You can open it up and see. All right. Let's just settle down and listen to what I have to say. So we have two lines cut by a transversal right here. And we learned some words, didn't we? We learned corresponding angles. Well, most of us did, according to that quiz. Not everybody did. All right. But most of you did. Learn alternate interior angles. You learn corresponding angles, consecutive interior angles. Remember all that stuff? All right. So we learned that in one lesson. Then the next lesson, we learned something about these two lines. We said that these two lines, if I put an arrow right here, these two lines were what to each other? Parallel. So we learned that if the two lines are parallel, cut by transversal, then the alternate interior angles, we knew something about the alternate interior angles. What did we know if we had parallel lines? That they're equal to each other. Okay, what did we know about the corresponding angles, like this one and this one are corresponding? What did we learn about those? No, no, they don't. Corresponding angles, what are they? No, they don't. They add up to 180. They're equal. Okay, corresponding. No, I heard add up to 180. I heard supplementary. I never heard equal. All right. So anyway, they're equal to each other. We knew that alternate exterior angles were equal to each other, right? So this one right here and this one right here. Those two are alternate exterior angles. We also look at this. We also talked about these. Let's see, this one right here and this one right here. What name did we give this one and this one? Consecutive interior angles, right? But what did we say about consecutive interior angles? They weren't equal. They were supplementary. They add up to 180. Okay, so this angle and this angle add up to 180. Everybody see that? So really, if you look at it, all the acute angles are equal to each other. All the obtuse angles are equal to each other. But the obtuse angle and the acute angle, what's the relationship between those two? They're supplementary. Okay, so any obtuse and any acute in this particular situation would be supplementary. Does that make sense? Okay, so that's just old stuff. Okay, that's stuff that we learned before. All that was contingent on what fact? That what? That the lines are parallel. Okay, I can't say anything about those angles being equal to each other unless I knew that those lines were parallel. You follow me? So this is what we said. We said if, I'll just say this. I'll just shorthand it really quite a bit. If we have parallel lines, let's try the I first. Here we go. If we have parallel lines, then blank dot dot dot. All that stuff is true, right? Let's just list it real quick here. The alternate interior angles are what? Equal. Actually, I should have started with this one, the corresponding. Remember that was a postulate, the corresponding angles. So the corresponding angles were equal to each other. My writing's terrible when I try to write small like this, but all right. So if you had two parallel lines, if you have parallel lines cut by transversal, if all that stuff is true, then what's true? Alternate interior angles are equal. Corresponding angles are equal. Alternate, what else? Exterior angles are equal to each other. Was there anything else? That was it for all the stuff that was equal, right? Yeah. But then we also said that what? Then consecutive interior angles were what? Not equal, but supplementary. Good. All right, we're supplementary. But what was that all dependent on? If what? If the lines are parallel. So look at my statement. If the lines are parallel, then all this stuff is true. It's an if-then statement. If-then statements are very important in math, especially in geometry. You see them all the time. Many, 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 many theorems and postulates that we're going to be discussing are in that form. If something is true, then something else is true. All right? If the lines are parallel, that's a big if. If the lines are parallel, then you can say all this stuff about it. then the alternate interior are equal, then the corresponding are equal, then the alternate exterior are equal, then the consecutive interior are supplementary. Does that make sense? So it all depends if you have parallel lines. But watch what we're going to do today. We're kind of going to do the opposite. We're going to take the if and the then, and we're going to switch them around. All right, so what do you think we're going to say? Let's start with corresponding first. If the corresponding angles, actually, it would start off like this, if you want to be real technical. If two parallel lines are, I'm sorry, I misspoke. If two lines, not parallel, if two lines are cut by a transversal and the corresponding angles, see, I left a lot out, didn't I? Okay, if two lines are cut by a transversal and the corresponding angles are equal, then what do you think must be true about the two lines? I'll say it again. If you have two lines, I didn't say anything about the two lines, did I? If you have two lines and it's cut by a transversal, all right, so far so good, right? And if you knew that the corresponding angles were actually equal, somebody told you that the corresponding angles were equal to each other, what do you think then you could probably say about those two lines? That they're parallel to each other. Exactly right. Do you see how it's kind of the same but different? So we're starting off saying if the corresponding angles are equal, then you have parallel lines. I just really shortened it right here, okay? So technically it would be if two lines are cut by a transversal and the corresponding angles are equal, then the lines are parallel. Make sense? Okay, let's draw the picture. So if you have two lines, and notice what I said. I just said two lines, didn't I? I didn't say anything about the two lines. I just said you had two lines. And if they're cut by a transversal, now that's not all we know though. Okay, what else do we know? We know that the corresponding angles are what? Are equal to each other. So if I said that this angle is equal to this angle, what's the relationship between those two yellow angles? They're corresponding, right? And they're equal to each other. So if the corresponding angles are actually equal to each other, now right now, before I put those two angles there, did I know anything about those two lines as far as being parallel? No, they kind of look like they are, don't they? But does that mean they are just because they look like it? No, you have to be told. All right, so right now I'm not really sure if they're parallel, but somebody measured it and said, okay, this angle, call it 1, and this angle 2, those two angles are equal to each other, right? Because they both have one arc on it. If those two angles are equal to each other, guess now what you can say about those two lines. Then they're parallel, all right? So watch, we'll put an L and an M right there. All right, so watch this. We could say this. If angle 1 is equal to angle 2, then, right? You follow me on that? Because I got two lines cut by transversal, and if those two angles are equal to each other, they're both corresponding angles. If they're equal to each other, what then could I say about the two lines? That L is parallel to M. Does that make sense? And that it's kind of the same as what we did before, isn't it? Except we kind of flip-flopped it a little bit. Instead of saying if the lines are parallel, then the angles are equal, what do we say? If the angles are equal, then what? The lines are parallel. You see it? So the title of this lesson, somebody asked me earlier, the title of this lesson, it's Proving Lines Parallel. All right? So that's really why they call it that lesson. We're proving that the lines are parallel. So if I know that the corresponding angles, then the lines are parallel. Now, is that the only thing that I need to know in order to show that those two lines are parallel? No. I could also, let's keep the yellow theme going right here. Let's say that, right? I could say if angle, let's keep this color coordinated here. I could also say what? If angle 1 is equal to angle 3. What's the relationship between angle 1 and angle 3? What are they to each other? Alternate exterior angles. That's right. So if angle 1 is equal to angle 3, if that's all you knew, let's say you didn't know anything about angle 2, but let's say you knew that 1 and 3 are equal, is that enough to say that the lines are parallel? Absolutely, because if the alternate interior angles are equal to each other, then the two lines are parallel. So then I could say that L is parallel to M. Make sense? What's another one that I could say? If what? If the corresponding... Oh, I know what I need. Let's go... let's put a 4 right here. Is that all right? So what if angle 2 equals angle 4? Is that enough to say that they're parallel? Yeah, it is. Why? Because what's true about 2 and 4? They're what to each other? They're alternate interior. Okay, so that means if the alternate interior angles are equal, then the two lines are parallel. We getting this? All right. What's one more, but not equal? What if I said, let's do this. Let's put another angle in here. Let's put a 5 right there. But I don't put one arc here, do I? I put 2 arcs right there. Okay. All right, Dominique, tell me. If angle what? 5? Okay, good. That's a good way to say it. Perfect. If angle 5 is supplementary to angle 2, right, then what's true? If 5 and 2 are supplementary, if they add up to 180, what must be true about these two lines then? They got to be parallel to each other. Okay? So there you go. It's kind of like the same thing as we did before, except we're just going backwards. Instead of saying if the lines are parallel, then all that stuff is true, right? What do we say now? If any one of those things is true, right, about the the corresponding angles, alternate interior angles, if any of that stuff is true, then those two lines are parallel to each other. And that's the kind of stuff they're going to ask you. They're going to say, show why they're parallel or something. Let's see. Or it'll say like find X or find Y so that L is parallel to M. Everybody hear me? So it'll say, and I'll do an example right now, all right? Because I'm sure that's what you want to see, isn't it? Yeah. All right, so let's draw a couple lines. Now, right now, as of this moment, I don't know that they're parallel to each other, do I? Seems like I'm drawing it the same way every time. This is going to be an example, yeah.
Put another line. Make the other one.
I could make it the other way. Actually, let me see what they do. Let me find a good example here. Okay, let's do this. Let's get rid of this stuff. Sorry. Yeah, I just want to make it look a little different. So there's one that's a little different in the book. So one goes like this, because it's not always going to look the same every single time. Like that. And let's make let's make it like that. Okay. Alright, there we go. There's our situation. And we call this one M. And we call this one N. And here's what they tell you. They tell you that this angle right here is 4x minus 23 degrees. Now, when they stick it right here, you know where it's between this side and this side, so it's this angle right here. Everybody understand that? How to label it? And they say this is 2x plus 17 degrees. So this one is 2x plus 17 degrees. And here's the question. It's not hard. The math is pretty much exactly the same as what we did before when they told you the lines were parallel. All right? The math is pretty much the same, but you're just finding something different. And it says, find x. It says, find x so that M is parallel to N. Because right off the bat, we don't know they're parallel. But let's find out what x should be equal to in order to make M and N parallel to each other. So how do I make M and N parallel to each other? Well, what's true? What's the relationship between these two yellow angles? Alternate exterior angles. So if the alternate exterior angles were what? Equal, then what must be true about the two lines? Then the lines must be parallel. So we're trying to find out what x is going to be in order to make those two lines parallel. Does that make any sense? All right, so how do we find x then? We set them equal, right? Okay, we need to put them equal to each other to make those two lines parallel. So like I said, the math is really no different than what you did before. So we just set them equal to each other. All right, so subtract 2x, added 23, which would be what, 40, and x is 20. So if x is 20, then these two lines are parallel to each other. You get it? And if x is 20, that means these two angles would be the same. And if the two angles are the same, then it means these two lines would be parallel to each other. All right, if x was equal to 20. That's all there is to it. Really, the math is not much different. And we just proved it. Yep, because that's what x has to be in order to make m and n parallel to each other. Because if it was 20, guess what this would be? 4 times 20 is 80. 80 minus 23 is 57. Did I do that right? Okay, so that would be 57 degrees. Now, if you look at this, does that even look like 57 degrees? Okay. No, it looks obtuse, doesn't it? But remember, you don't always just go by what it looks like. Don't let that fool you. All right, just go by the numbers. What about this? 2x, 2 times x, that's 40, right? Plus 17 is what? 57. So it makes those two equal, doesn't it? All right, and it should if we did the math right. Right? You put x in for both of those, it should make them equal to each other. So if the alternate exterior angles are equal, then the lines are parallel. Now I can say that m is parallel to n. And that's the kind of stuff they're going to give you there. All right? It's not so hard, is it?
Is that it?
Maybe. Let's do this. Yeah, maybe a little bit. It's the same idea, though. Everything will pretty much be the same idea. Let's try this. You writing this down? David, why don't you put that piece of paper away and see what we're doing. Oh, look at this craziness.
Is it in the book?
It's in the book. We'll go yellow. 1, 2, 4, 3, 5, and 6 right here. 7 and 9 right here. Down here is 8 and 10. Alright, and this line is L, this line is M, this line is J, and this line is K. Alright, here's what the deal says. It says, given the following information, determine which lines, if any, are parallel. State the postulate or theorem that justifies your answer. So here's number 1. Number 1 says, alright, they're going to tell you that angle 1 equals angle 3. Alright, so let's come up here and take a look at it. Here's angle 1. I'm going to mark it. Here's angle 1. Here's angle 3. They told us that they were equal to each other. Now, by knowing that information, by knowing that angle 1 is equal to angle 3, does that tell us anything about whether any of these lines are parallel to each other? First of all, what's the transversal between those two angles 1 and 3?
L.
L, right, because L is the common side between angle 1 and angle 3, right? So what are my two lines that are being crossed by that transversal? J and K, right? Because do you see that? Because this connects L and J, this connects L and K. So L is the common line, so that's got to be the transversal. J and K are my two lines. Now, is there a relationship between 1 and 3? Here's my two lines, here's my transversal. What's the relationship between 1 and 3? What are they? They're corresponding, right? So, what did we just learn? If the corresponding angles are what? Equal to each other, what must be true about these two lines then? They have to be parallel, okay? So, the question is, what lines must be parallel? J must be what? Parallel to K. And that's how I would write my answer. J is parallel to K. Now, it says, state a postulate or theorem. So what would you say? Yeah, I would just say this. I would just say corresponding angles are equal. That's what I would do. So if the corresponding angles are equal, then the lines are parallel. That's what their theorem basically says, all right, in a shortened version. All right, so if the corresponding angles are equal, then those two lines have got to be parallel. Does that make any sense on how to answer those questions? You'll have a big chunk of those on your homework, okay? It's not that hard. What about this one? What about, here's another problem, angle 2 equaling angle 5. All right, and let's get rid of this now. So it's a new problem. We don't really know that 1 and 3 are equal to each other, but we do know in this problem 2 and 5 are equal. So let's mark it. So 2 and 5 are equal. All right, let's take a look at that. First of all, take a look to see which one is the transversal. Look at 2. It connects what? J and L, right? Look at angle 5. It connects what? L and K. Which is the common side between them? It's L. So that must be my what? transversal. Let's stop with the paper, okay? I can't take that anymore. So look, so what are your two lines then? J and K. Now, are they parallel yet? Well, we got to make sure that 2 and 5 are equal, right? And what's the relationship between 2 and 5? Alternate interior angles. So if the alternate interior angles are equal, guess what's true about the two lines? They're parallel. So that's exactly what we say. And what are our two lines again? J is parallel to K. And what's my reason? Alternate interior angles are equal. All right? So that's how we write down our answer. Brooke?
I don't get how you tell the difference, like, if that's alternate interior, but then, like, what would be alternate exterior?
Alternate exterior would be like 1 and 6. Do you see that? Because it's on the outside. So here's your two lines right here, right?
Oh, interior.
Here's your transversal. See,
Okay,
2 and 5 are in between the J and the K. You see it? So the J and the K slant like this. The 2 and the 5 are in between.
Oh,
The 1, see, the 1 is outside the J and the 6 is outside the K, right? So they would be exterior, alternate exterior angles. 2 and 10, there's really no relationship between 2 and 10. Because look what 2 does. 2 connects J and L, right? Look at 10. It connects K and M. Do they have anything in common? No, so they don't have a common transversal or anything, do they? So you can't say anything about it. It's not two lines cut by one transversal. So there's really no relationship between 2 and 10 as far as the names that we've been given. Okay? Let's do another one. Let's get rid of some of these just so I can keep my picture up there. Oops. There we go. Yeah, that's what I'm going to try to find. I think they should have one on here. That's weird. They don't have one on this, but we could make one up. I'll tell you what. Let's do this. Let's go 4 and 7. So, so angle 4 equals angle 7. So let's mark that. Here's angle 4. Here's angle 7. So let's take a look at this. Now, what two lines is formed by that, or what two lines form that angle right here? Well, L and what? J. What about angle 7? M and J. What's the common thing? It's J, isn't it? So J must be my transversal, okay? So that must mean what? L and M must mean my two lines. Is there a relationship that we know between 4 and 7? Yeah, they're alternate interior angles, aren't they? Okay, they're alternate interior angles between L and M. Do you see it? This is the transversal. These are my two lines. 4 and 7 are alternate interior angles. They're equal to each other because they told me that it's equal to each other. So what must be true about these two lines, L and M? They got to be parallel. And why? Because alternate interior angles. Now, I should have said this. Remember how I switched the if and the then around? Because the first time it said if the lines are parallel, then the alternate interior angles are equal. Then what did we do? We switched it around and said if the alternate interior angles are equal, then the lines are parallel. We actually call that the converse. All right? The converse means you switch the if and the then. All right? So we could say it's the converse of alternate interior angles being equal. Okay? Interior. I probably won't be super picky on that. I'll understand what you mean if you just say, well, the alternate interior angles are equal. But you might look in the book and they might say that, so I want to make sure that you know why they said that, okay? The converse of it. Okay? Let's make one up now. Because in the book they made it too easy. Let's get rid of these. And get rid of that. What about 5 and 10? Angle 5. What if I said angle 5 was supplementary to angle 10? Look at it. What if I said this was supplementary to this? Would that just by itself say anything about parallel lines? It is two lines. It is transversal, but is there any kind of relationship between 5 and 10? Are they alternate interior? No, because that's an exterior. Are they alternate exterior? Are they corresponding? Are they consecutive interior angles? No, because that's not interior again. So there's real no direct relationship, is there, between 5 and 10? So just because I know that they're supplementary does not necessarily mean that these two lines are parallel. Kind of in an indirect way, they would, because watch, if I said this was 11, then what's true about 10 and 11? Why are they equal? Because they're vertical angles. Very good. So they are equal. So now what can I say about 5 and 11? They are consecutive interior angles, aren't they? And if these consecutive interior, so if 11 is the same angle as 10, 5 and 11 must be what? Supplementary as well, right? So in an indirect way, yeah, these two lines, L and M, would be parallel if 5 was supplementary to 10, but not directly. So I'm not sure what they would do about that. I would probably say, you know what? I would probably change my mind a little bit. I would say yes, L and M are parallel if 5 and 10 were supplementary. But your reason would be you'd have to go vertical angles first, right? So one of your reasons is going to be vertical angles, so 10 and 11 are equal because of vertical angles. And then this right here is the converse of consecutive interior angles are equal. Okay, so I would actually use 2 because you got to think ahead a little bit. It's not directly; they don't relate directly, but kind of indirectly. You see what I'm saying when I say indirectly? You know, 5 and 10 don't have a special name for it, but 5 and 11 do, and 11 and 10 are the same exact angle, right? So I could just say, well, 5 and 11 are supplementary, and because 5 and 10 were supplementary, because 10 and 11 were equal. Does that make sense?
So what would be the answer?
So I would just say, yes, they are. I mean, L and M would be parallel to each other. And I would give 2 reasons instead of 1. I would say 10 and 11 are equal because of vertical angles. And then these lines are parallel because 5 and 11 are consecutive interior angles. So I would use 2. I would use vertical angles and consecutive interior angles. So I would use 2 reasons for that. Okay? Does that make sense? Or supplementary, right? If the lines are parallel. No. See, I was given that the consecutive interior angles were supplementary, so I was given that. I had to know that. I can't just say any old 2 lines, the consecutive interior angles are always going to be supplementary. It's only true if the 2 lines are parallel, okay? Yep. I haven't heard of it. You probably could make that up. Let me give you some problems to do, okay? We covered everything, pretty much. So, let's see. Section 3.5, page 209, and you're doing 8 to 21. It's not that bad. All right, there it is right there. All right, have a good weekend.